Hi everyone, welcome to my channel CyberUnnat Academy. This is the second video of Certified System Security Analyst. This is a self-placed certification program. For the previous video, you please check into this playlist or a course where you are looking. So this is the second video, and here we are saying of module 1, understanding of cybersecurity fundamentals, and where we are saying lesson 2, the CI triads and cybersecurity principle. Previous lesson, you will see my previous video, module 1.1, introduction to cybersecurity. So let's start lesson 2, the CI triads and cybersecurity principles. Okay, let's jump to our lesson 2, the CI triad. So basically, CIA is a short form for a confidentiality, integrity, and availability. CIA. So these are three major pillars of the cybersecurity, and for any business also. So confidentiality, it's ensuring information is not accessible by a authorized individual. So that is to maintain maintaining a access to the authorized person only. That is the confidentiality. Integrity. Integrity is ensuring that data is not altered or tampered with any other thing. Means maintaining a originality of data is the integrity, and availability is ensuring system and data is accessible when needed to authorized person. Okay, end users, etc., authorized person. So this is a CI triad. So confidentiality simple, uh, not accessible by unauthorized individual. It's like maintaining a confidentiality. With respect to confidentiality, we also need to maintain integrity. Data is not altered or tampered in an unauthorized way. Availability also, also with this we need to maintain availability, ensuring that system is available to authorized user, data is available to authorized user in the original form and whenever needed. So this is a CIA triad. So CIA triad is like we need to maintain a CIA triad. If we maintain the CIA triad, that's we can say that we implemented a security for the any organization or anything, or onto your personal also, personal things also. Okay. So confidentiality, we'll see in detail. Goal is to prevent unauthorized access to a information, whether it is sensitive or non-sensitive. So to the information. So the concept is only authorized person should have access to the specific data or system. Like, and we also need to ensure privacy and protect the proprietary or a personal data. Techniques to ensure confidentiality is encryption, like convert data into say secure format. Then access control, role-based access control or attribute-based access control, that is given. Multi-factor authentication, like adds an additional layer beyond your password. So along with password, we need a mobile OTP. So that is an example of multi-factor authentication. And data classification. So data classification means labeling and managing the data. Suppose we are managing data, some data is like public use, some is for private use or personal use. So like this is a data classification. So these are the techniques. One of the few techniques to ensure the confidentiality. Then what are dangers, threats, dangers to confidentiality? Uh, Threats are eavesdropping, insider threat, data breach, and unencrypted data transmission. So don't worry if you're not right now, if you're not correlating with these words, but later on we will also covering what are these insider threat, data breach, etc. But you can say these are the threat to confidentiality. Insider threat basically, as the name suggests, it data breach and encrypted data transmission. The second is integrity. Integrity that ensures the data is accurate, consistent, and unaltered. So it should be accurate, it should be consistent, consistency mention, and unaltered also. Key concepts are data should be trustworthy and maintain its in its original state only. Okay, like someone is not changing anything. Protect against unauthorized modification, deletion, and corruption. So unauthorized modification, deletion, and a corruption also, like we need to protect also from the technical fault. Not only a human or intentional fault, but also a technical fault. Techniques to ensure integrity, like checksum and hash functions that validate the integrity, digital signatures, version control, and the audit trails. These are some techniques to ensure the integrity. Threats to integrity, man in the middle attack, malware, unauthorized modification, and data corruption. So these are some dangers to the integrity. Availability. Availability ensures system and data are accessible when needed. Key concepts are unauthorized user should be able to access resources without disruption. So sorry, authorized user should be able to access resources without disruption, and unauthorized user should not access, that we covered in the confidentiality. Ensure the business continuity and operational uptime. This also ensured in the availability. So techniques to ensure availability, like redundancy systems, backups, data replication, disaster recovery planning, business continuity planning, load. This is like technical load balancing technique, distribute traffic to prevent the server overload, etc. And DOS protection, like filter, mitigate, attack traffic. These are the one of the techniques to ensure the availability. Again, threats to availability, like a DOS attack, denial of service, distributed denial of service DOS attack, hardware failure, natural disasters, software bug and misconfiguration also, that can be a threat to a confidential, sorry, availability. Uh, Here are some real world example of to apply CI triad. So we'll see one healthcare system is there. So what will be a confidentiality, like encrypting the patient medical record. So suppose you are a patient, you submitted a blood report. Okay, you applied for a blood report, you collected blood sample, and now your blood report entirely is a medical record. So that, like, should be encrypting that record. Integrity means ensuring the diagnosis report are not tampered with. It is in the original state. Like anyone should not have a edit access or a alter access to that report or to that computer where the reports are stored. And availability, like making sure that your record, the patient record, is accessible during the emergency or as needed. Suppose all the stakeholders will be like to you, your concerning doctor at that time, or a insurance company. So these guys should be able to access your reports whenever it is required. Why CI triad is important? Risk management. It help organization to identify, address, and the security gaps. So risk management, compliance, to meet the compliances also, many regulations, HIPAA, GDPR, PCI DSS, ISO, etc. are the built around these principles. Incident response, help and prioritize action during the and the after security events. And the security architecture also, it guides the design of secure system and the network. So this is a CI triad. Let me know in the comment, or you can reach out to me on my Instagram channel @CyberUnnat if you have any questions or any follow-up. So next topic is principle of least privilege. As its name suggests, least privilege means like this is a security concept that dictate user, system, or procedure should be granted the minimum level of access or permission necessary to perform their task. Okay, so see, minimum level of permissions required. Just like, let's take an example of a security guard, like which securing a building. So minimum level of permission like a security guard is required, maybe only to your main gate for the opening and closing, and maybe he maybe having possession of the keys, not the possession of the main door of the main door of your house. So minimum level required. So just like you also you are accessing some website, okay? So what happening in the website? You are just able to see if the website don't have a like login page or etc. You just need to see means that is like a read-only access provided to you. You cannot edit that website, or the backend console is not accessible to you. Because why? Only as a end user you just need to see the website and get the information. You need not to alter, need not to publish a new content on the website. So that's why. So what are the key points in the POLP concept? Minimize the attack surface. Suppose unnecessary we are giving access like edit access, execute access to the other level, so that will like maximize the attack surface. Like it's POLP limits what the attacker can do if they gain access. Suppose I have a read-only access to a website, and suppose my access compromise. So the attacker also can have only read-only access, so he can't do the alter work. That's the minimize the attack surface. Reducing the insider threat, less privilege means less potential to damage. Insider threat means anyone you trust and he is misusing his privileges. Okay, that is the insider threat. Improve compliance, helps to meet regulatory requirements, that is GDPR, HIPAA, etc. As I said, like example, see a database admin has a full access to the database, but not the HR system. Okay, and the HR will not have access to the database. How to implement role-based access control? Like see, database admin need admin to the database, but not to the HR system, and the HR only have admin access to the HR, not to the database. So this is a role-based access control. Regular audits and permissions, and the revoke access when needed, like after project completion or employee offboarding. So that is the also like implementation tips. And use just-in-time feature like access model for a temporary elevation. So, suppose someone expert is coming to solve any problem. So suppose he need only just 2 days access to a system. So only for 2 days you provide access to him, and later on you can automatically, like if automated system or manual system, you revoke their access. So that is the concept of just in time. So second, another concept of cyber security principles are defense in depth. Defense in depth is a like a layer security strategy where the multiple defensive mechanisms are deployed throughout a IT system to protect data and the maintain integrity uh, at every layer. So suppose even if one layer is compromised, another layer will be there to protect. So we need to maintain a security at every layer. So I want to show some example to you. Defense in depth. These are some we are taking example from a just a minute. I'm taking it from internet. Okay. Mm, so open image in new tab. Okay. So see, this we take. Thanks for this website. We are just taking as a reference of this page. So see how the layered security works. So see your perimeter security, network security, endpoint security, application security, data security. At every layer, suppose we maintain defense in depth. So like a perimeter security, we'll just have like DDoS protection, firewall, IDS, IPS, DMZ, VPN, two-factor authentication, WAF, honeypot, etc. This is like a very first layer. Is kind of like also a physical security. Then coming to a network security, IDS, IPS, internal firewall, wireless security, mobile security. Then endpoint security in like a the softwares install on your host, application security, the softwares install on your application server. Data security is containing the database layer. So see physical layer, network layer, end user layer, application layer, and database layer. So every layer there is a security. Suppose these two layer breaches, till we have a endpoint security, application security, and also a data security, like data is encrypted, etc. So that will reduce the risk. So that's why layered security approach is required. For every layer we need to implement a security. So that is a defense in depth strategy. So what are all the benefits to it? Redundancy, delay and detect. Suppose every layer is breaching, we can set a like alarm. Suppose physical device breach, we will get alarm. So till then we will have time to secure rest of the layers. So this is like a delay and detect. And comprehensive coverage protects against wide range of the threat. So that is a defense in depth strategy. Simple. Any doubt? It's like a implementing security at every layer. Just like take a real world example of your home. You will have a at the main gate also you will have a lock, and suppose CCTV camera. At the main door also you will have a, like couple of locks, CCTV camera, maybe alarm system, etc. Or maybe a dog also. And inside your bedroom is also lock and have the like insider lock, not the external lock. And then again your safe like place in the bedroom or wherever in the, that also have a lock. So okay, so that is a like example of a layered security. At every layer we are implementing a security. uh, Next security principle is zero trust, security by design, and zero trust. Security by design means security is integrated into the system from the outset and not added later. So this means when you're building some applications or a home or something or a mobile phone or etc., whatever suppose you are building, when you're thinking of its design, so that you integrate a security into in its design phase itself. Not the like suppose first you are building a home and then you are thinking of adding a security. So that is not a concept. So later on you need to do lots of changes. Suppose you build a home and later you decided to okay you need to change this lock to another kinds of locks, or you need to build again a perimeter wall, you need to increase the height of the main gate. So if we need to changes later, that will be a time consuming, cost consuming also, and the complex task also. So that's why in the design phase itself we need to integrate a security. So practices are like for the software, there is a SDLC process, SDLC software development lifecycle. So we have a secure software development lifecycle. The threat modeling during design, code review, security design, and security default configurations. So that is the concept of a security design. To practice this, there is also this is a vast different field for the like a application security, a software development life cycle. So these are related to a cyber security concepts. Zero trust model, like never trust, always verify. So that is like a trust no device or a user, even if they are inside the network. So like even if you are aware of it, even if you are aware of everything, you know someone, but don't trust them, always verify at every layer at every time. So that is the concept of zero trust model. Just like we are entering username and password to our corp laptop every time. So even if suppose you are in the organization and you are sitting in front of the laptop in front of the admin, but how our laptop set, that is whenever you are powering on, every time you need to enter password. So that is a never trust, always verify. So in the security also, we need to implement the same zero trust model principle, that is never trust, always verify. So see, a security guard, suppose you are entering into a building, he always check your ID card, even if like you are known to him daily, you are like having a good morning or a good night during the evening, but he always like instructed to check your ID card while entering. So that is the best example of never trust, always verify. Verify explicitly, like always authenticate and authorize both things. Use a least privilege access tied with closely with POLP, and assume a breach. So assume a breach means always assume bad things while implementing a good thing. So that will help you to think in that way, that you will cover all the possible bad happening to a design. Like see, assume breach means like design a system that if attacker is already inside, like always think that it can be breached in this way, that way. So that is a assume breach. So technologies supporting zero trust like MFA, multi-factor authentication, identity access management, micro-segmentation, and endpoint detection and response EDR. So this is our lesson 2 in this course series. So till now in this video we covered lesson 2, and the previous video you will have a lesson 1.1. So in the next video we'll cover lesson 3, common cyber threats and attack vectors, and we'll meet into the next video. And if you also need information about this course, so you can see the very first video, introduction to CSSA video, that I'll put this video on the same playlist and the course, so you will have an index on that video. So how to obtain a certification, basically that instruction is given in that video. I'll show you that video. So if you go to YouTube, come on, yeah. So into my playlist, you will see courses, and into this courses, you will see very first video. This is introduction to a CCSA. So this video will show you. This video will give you information about this program that I'm currently conducting, and also there is a like a registration form. This is a course. This is a course starting playlist. This is a registration form where you can register, and you go through this video. There are instructions how to obtain a certification for you once you completed this course. Okay. So till then, I'll work on our lesson 3, 1.3, and we'll upload. So till then, take care, bye, and let me know anything if you have in the comment, or reach out to me at my Instagram page @CyberUnnat.